Welcome to our channel. Today we're diving into the cosmos to uncover some truly mind-blowing facts about space. So, buckle up, space cadets, and get ready for a cosmic adventure that will leave you questioning everything you thought you knew about the universe and our place in it. You know, it's easy to think of space as static, unchanging. But that couldn't be further from the truth. Inflated. Imagine baking raisin bread. As the dough rises, the raisins move farther apart. That's kind of what's happening with galaxies in the universe. It's not that the galaxies themselves are moving through space. It's that the space between them is stretching. And this expansion, it's not slowing down. In fact, it's accelerating, like a runaway train in the vast cosmic night. And the driving force behind this acceleration? We call it dark energy, one of the biggest mysteries in astrophysics today. If the expansion continues to accelerate, the universe could become a very lonely place, with galaxies spread so thin that they become like isolated islands in a sea of darkness. So the next time you gaze up at the night sky, remember, it's not a static picture. It's a snapshot of a universe in motion, always growing, always changing. Let's talk about black holes, those cosmic monsters that lurk in the depths of space. These things are so dense, with so much gravity packed into such a small space, that nothing, not even light, can escape their pull once it crosses the event horizon. Imagine a star, much more massive than our sun, collapsing in on itself at the end of its life. The gravity becomes so intense that it creates a singularity, a point of infinite density where the laws of physics as we know them break down. Around this singularity is the event horizon, the point of no return. Cross that boundary and you're going in, no matter how powerful your spaceship might be. But here's the thing about black holes. They're not just cosmic vacuum cleaners, they actually play a crucial role in the evolution of galaxies, influencing the formation of stars and shaping the structure of the cosmos. Black holes are still shrouded in mystery, but with each passing year, we're learning more about these enigmatic objects and their role in the cosmic drama. If black holes are the heavyweights of the universe, then neutron stars are the featherweight champions, at least in terms of size. These incredible objects pack the mass of 1.5 suns into a sphere the size of a city, like Manhattan Island. Now, imagine squeezing all the matter in the Empire State Building into something the size of a grain of sand. That's how dense a neutron star is. These extreme objects are formed behind its incredibly dense core. The protons and electrons in this core are forced together, forming neutrons. What's left is a rapidly spinning object with a powerful magnetic field, emitting beams of radiation from its poles. Neutron stars are like giant atomic nuclei, and studying them allows us to understand matter under the most extreme conditions imaginable. Let's talk about scale. Our planet seems pretty big, right? 7 continents, vast oceans, towering mountains. But compared to the universe, Earth is just a tiny speck of dust, adrift in a cosmic ocean of unimaginable size. Think about our solar system. It takes light, traveling at 186,000 miles per second, about 8 minutes to reach us from the sun. Now imagine traveling at that speed to the edge of our solar system. It would take you over 4 years. And that's just our little corner of the Milky Way galaxy, a swirling collection of hundreds of billions of stars. If you could shrink the Milky Way down to the size of North America, our solar system would be smaller than a grain of sand. The universe is vast and mysterious, and we're just starting to scratch the surface of its secrets. Here's something that'll really blow your mind. We can only see about 5% of the stuff that makes up the universe. The rest, about 95%, is made up of things we can't see or directly detect. We call them dark matter and dark energy. Let's start with dark matter. We know it's there because of its gravitational effects on galaxies. Galaxies are rotating so fast that they should fly apart if they were only made of the matter we can see. There must be something else holding them together, something invisible that doesn't interact with light. And then there's dark energy, even more mysterious than dark matter. It's the force responsible for the accelerating expansion of the universe, pushing everything farther and farther apart. We don't know what dark matter and dark energy are made of, but scientists are searching for answers using some of the most advanced telescopes and particle accelerators ever built. Let's take a trip back in time, all the way back to the beginning of everything. I'm talking about the Big Bang, the event that birthed the universe as we know it. Imagine a point of infinite density and temperature, smaller than an atom, suddenly expanding outward in a massive burst of energy. That's the Big Bang. As the universe expanded and cooled, energy converted into matter, forming the first subatomic particles, then atoms of hydrogen and helium. Over billions of years, these atoms clumped together under the force of gravity, forming stars, galaxies, and everything else we see in the cosmos. The Big Bang theory is supported by a wealth of evidence, including the observed expansion of the universe and the cosmic microwave background radiation, a faint afterglow of the Big Bang. Even with unanswered questions, the Big Bang theory remains the best explanation we have for the origin of the universe, a story that's still being written 13.8 billion years later. For centuries, humans have wondered if we're alone in the universe. Now, thanks to advances in astronomy, we're closer than ever to finding an answer. In recent decades, astronomers have discovered thousands of planets orbiting other stars in our galaxy. We call them exoplanets. These exoplanets come in all shapes and sizes, from gas giants larger than Jupiter to rocky worlds like Earth. Some orbit their stars in the habitable zone, the region where temperatures are just right for liquid water to exist on the surface, a key ingredient for life as we know it. The search for life beyond Earth is one of the most exciting frontiers in science. With powerful new telescopes coming online, we're poised to make groundbreaking discoveries in the coming years. So, keep looking up, fellow space enthusiasts, because the universe is full of possibilities. Let's take a closer look at our own cosmic neighborhood, the Milky Way galaxy. It's a barred spiral galaxy, a vast city of stars with a central bulge and graceful spiral arms that stretch out for thousands of light years. Our solar system resides in one of these spiral arms, about 26,000 light-years from the galactic center. From our vantage point, we see the Milky Way as a band of light stretching across the night sky, a faint glow from billions of distant stars. At the very center of the Milky Way lurks a supermassive black hole, a gravitational behemoth millions of times more massive than our Sun. This black hole, Sagittarius A*, plays a crucial role in the dynamics of our galaxy. The Milky Way is constantly on the move, swirling and rotating through space. Studying the Milky Way helps us understand the formation and evolution of galaxies, as well as the history of our own solar system. Here's where things get really weird. We're used to thinking of space and time as separate entities, but in reality, they're intimately connected, forming a four-dimensional fabric called SpaceTime. Imagine a trampoline. If you place a bowling ball in the center, it will create a dip in the fabric. Now roll a marble across the trampoline. It won't travel in a straight line. Instead, it will curve around the bowling ball, following the curvature of the fabric. That's kind of how gravity works, according to Einstein's theory of general relativity. Massive objects like stars and planets warp the fabric of spacetime, and other objects, including light, follow those curves. This warping of spacetime also affects time itself. Time slows down near massive objects, a phenomenon known as time dilation. The concept of spacetime is one of the most profound ideas in modern physics, challenging our intuitive understanding of reality. Looking out into the vastness of space is like looking back in time. The light from distant galaxies has taken billions of years to reach us, so we see them as they were billions of years ago. Astronomers using powerful telescopes like the Hubble Space Telescope have been able to peer deep into the early universe, observing galaxies that formed shortly after the Big Bang. The farthest known galaxy, GNZ 11, is so far away that its light has been traveling toward us for over 13.4 billion years. Studying these distant galaxies allows us to trace the evolution of the universe from its infancy to the present day. The discovery of GNZ 11 and other distant galaxies pushes the boundaries of our observational capabilities, revealing a universe that is both ancient and ever-evolving. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content about space and beyond. So keep looking up at the stars, keep asking questions, and never stop exploring the universe and all its wonders.